So in this video, I'm going to show you an example where you have to use substitution and trig substitution. I guess you don't have to use trig substitution, but I've been making all these videos on trig substitution, so I'll show you a way that that could go down. So here's an example. So I've got e to the x over 1 plus e to the 2x dx. So a somewhat common, I guess, like thing that you have to do sometimes with substitution is for things like this that can be rewritten. So like this. So you could rewrite this as e to the x times e to the x. So this is a really common trick that comes up. It doesn't just have to be with e's, by the way. It could be like 4x squared you could think of as 2x times 2x. 9x squared is 3x times 3x. We could also get creative and say, like, if I had 4x, I could call that 4 square root of x times, 2 square root of x times 2 square root of x. So this is just like a really common trick that comes up with substitution, and the more calculus you do, the more quickly you will get at spotting this trick. So the whole thing about this is then when I take my u, I just set it to equal to one of those powers. So in this case, since I'm setting my u equal to e to the x, this looks almost a little odd. But the reason that I know that this is the right substitution is that when I take my du, that gets me the e to the x in the numerator, which I really need to cancel out. So let me clear out the rest of this. Okay, so then I'm going to set up my substitution, and now this becomes 1 plus u squared. Okay, and so from here, there's a lot of different routes I could technically go with this, but what I'm going to do is I'm going to use trig substitution, because that's what this video is about. And I always talk about using kind of a chart of like the most efficient selections you can make for trig substitution. So I'm going to use this x equals a tangent theta. In this case, my a will be equal to 1. So let's see. My u in this case is going to be equal to just tangent theta, right? Okay. Now my du then will be secant squared theta d theta. And so then I'm left with secant squared theta d theta over 1 plus tangent squared theta. And now the thing I like about this is then 1 plus tangent squared theta, so that will allow me to use this identity here. So I'm just going to set that equal to secant theta. So this is secant squared theta now over secant squared theta d theta. Now I can see this is actually a pretty simple integral. So I really like when trig substitution, sometimes this happens with trig substitution where it just makes the integral like stupidly easy. Now there are totally other times, right, where the trig substitution gets a little crazy in and of itself, but I like when this actually happens. So this is just going to leave me with theta. Okay, so now I have to recall, I got to come back over here to the u's. So my tangent theta equals u, so we could think of that as tangent theta equals u over 1. So if you think of your SOHCAHTOA, so this is opposite over adjacent, right? So here's my little reference triangle. Here's my theta, here's my opposite, here's my adjacent. So when I'm just thinking of then how do I solve for theta, so to solve for just theta in this case, I'm going to just take arctan or inverse tan. So this is going to be inverse tangent of u. And then inverse tangent of u, well, now we have to remember what does u equal, so we go down the line. So this ends up becoming inverse tangent of e to the x plus c. And so that'll be your final answer in that case. So there's just an example to kind of get you going in case you get stuck. You have other questions, you can always feel free to leave me a comment. I can always think about making other videos if you guys would find that helpful. And that's it for this video. I will talk to you guys in the next one. Thanks for watching.